Good day, everyone. This is Mom Grace, and welcome to your mathematics class. Let's have a recall. Geometric sequence is a sequence obtained by multiplying a common ratio to the preceding terms in order to obtain the succeeding terms, while a geometric series is the sum of all the terms of a geometric sequence. So before, we already have known the n-term formula of a geometric sequence, which is a sub n is equal to a sub 1 times the common ratio raised to the power of n minus 1, where n is the number of the terms, r is the common ratio, a sub 1 is our first term, and a sub n is our nth term. We also have discussed the common ratio, in which the formula is r is equal to the n minus 1 root of a sub n divided by a sub 1, where n minus 1 is the number of the terms in the sequence minus 1, and we have to extract the root of the quotient of a sub n, which is our last term, divided by our first term. Same legends use. R is the common ratio, n is the number of the terms, a sub n is our last term, a sub 1 is our first term. So what is a geometric series? In which it is a finite series. So to find the sum of the geometric sequence in which it is a finite sequence, it is otherwise known as the partial sum. So it is the sum of the terms in a finite geometric sequence. So let's recall condition number 1. So if r is not equal to 1, we will use the formula S sub n is equal to a sub 1 times the quantity of 1 minus the common ratio raised to n all over 1 minus r. So we have here the sum of the number of the terms. A sub 1 is the first term, r is the common ratio, and n is the number of terms. So these are the legends of the variables that we use in the formula. Example for condition number 1. Find the sum of the 7 terms of a sub 1 is equal to 16 and the ratio is 2. So since the solution is, the ratio is not equal to 1, that's 2. So we will be using the formula given to us earlier. Substitute the values. So a sub 1 is 16, 1 minus the common ratio, which is 2, raised to the number of terms, which is 7, all over 1 minus the common ratio, which is 2. Then let's have to simplify 2 raised to 7. So you have to compute 2 raised to 7. Using your calculator, you will get 128. So subtract it from 1 and then multiply it to 16 and divide it to negative 1, which is the answer of our 1 minus 2. So after subtracting 128 from 1, the answer is negative 127. Multiply it to 16 and the answer is negative 2032 divided by negative 1 is positive 2032. Now let's proceed to condition number 2, which is r is equal to 1, or the common ratio is positive 1. So the formula given to us before is S sub n is equal to the first term times the number of terms. So whatever is the first term, we will just multiply it to the number of terms. That's already the sum or the partial sum of the given sequence. We just have to make sure that the common ratio that we got is positive 1. So we have the example. Find the sum of the first 25 terms of 11, 11, 11, 11, and so on. So let's check for the common ratio. It should be positive 1, and that's correct. And since it has a common ratio of positive 1, then we will use the formula S sub n is equal to a sub 1 times n. So S sub 25 is equal to a sub 1 times n. And that is 11 times 25. So our first term times our n, 25, that's 275. Therefore, the sum of the first 25 terms of this sequence is 275. Next, condition number 3, if r is negative 1 and n is even. So the number of terms here is even as long as our ratio should be negative 1. So the formula for that is S sub n is equal to 0. So we don't need to compute here. We just have to put the number of terms in replacement tool n. So like for example, we have to find the sum of the first 36 terms of negative 14, 14, negative 14, 14, and so on. So check for the common ratio, which should be negative 1. That's correct. So since that's negative 1 and the number of terms here is 36, which is an even number, then we will use the formula S sub n is equal to 0. Therefore, S sub 36 is equal to 0. I hope you got it all correct since this is a very easy type of condition. Next, condition number 4, we have if r is negative 1 and n is even. So opposite of condition number 3, we have previously discussed n now is odd. And condition number 3, n is even. So same ratio should be negative 1. So the formula for that is S sub n is equal to A sub 1. So whatever is the first term will be the sum of the number of terms of the sequence, as long as the common ratio is negative 1. All right. Example. Find the sum of the first 47 terms of the sequence 17, negative 17, 17, negative 17. So we'll have to check for the common ratio. It should be negative 1. Yes, it's negative 1. So now we will be using the formula S sub n is equal to A sub 1. So we have S sub 47 is equal to 17, which is our first term. All right. So we will skip the live quiz. We will now go to our lesson proper, which is the sum of the infinite geometric sequence. So after we have recalled the 4 conditions of the finite geometric sequence or the finite geometric series, we will now go to the infinite geometric series or the sum of the infinite geometric sequence. So it is the sum of the terms in an infinite geometric sequence. So since infinite, it has no definite last term. So our friendly calculator will help us solve and go through the solutions of our problems. Now let's have the steps. First, determine the value of the common ratio. So condition number 1, if r is greater than or equal to 1 or r is less than or equal to negative 1, then it's impossible to get the sum. So that means we have to make sure that it will suit the condition. Okay, what should be the condition? It should be r is greater than negative 1 and r should be less than 1. So it is just between between negative 1 and 1. So negative 1 and 1 is not included in the solution because it will be here on this statement letter A. It should not be equal to 1. It should not also be equal to negative 1. But it should not be less than negative 1 and it should not be greater than positive 1. Okay? It should be within negative 1 and positive 1. The ratio should be within this range. So you already have discussed that during your grade 9. So when you have your range of the common ratio is between negative 1 and positive 1, then it is possible for us to get the sum of the infinity. Okay, if not, we will not continue. So if it is possible to get the sum, then you will use the formula. Okay, the formula is S of infinity is equal to A sub 1 all over 1 minus R. So if you have noticed the formula of our sum of the finite sequence, we have 1 minus r also in the denominator. But for now, this symbol means infinity. So let's have the infinity. The first term is still a sub 1. R is still the common ratio. S sub infinity is the sum of the geometric sequence to the infinity. Alright, so let's practice using your calculators. Find the sum of 8, 4, 2, and 1, and so on. So first things first, we have to solve for the common ratio, and that's 4 over 8, which is equivalent to 1/2. I will not be giving already the steps here since we have discussed that previously. So since the R is 1/2, then it is possible to get the sum because it was stated in letter B that it should be less than positive 1. Okay, so 1/2 is less than positive 1, so we can proceed with getting the sum to infinity. So the sum to infinity formula says that a sub 1 all over 1 minus R. So our a sub 1 is 8, our R is 1/2, so that's only sum to infinity is equal to 8 over 1 minus 1/2. So for 1 minus 1/2, the answer is 1/2. And then divide 8 by 1/2, and the answer is 16. So that's 8 times 2 over 1. It will be looking like this. So let's use the pen. So we have 8 times 2 over 1 is equal to 16 over 1, which is also 16. Okay, so that's it for example number 1. Number 2, what's the sum to infinity? So we have 96, 48, and 24, and so on. So you have to check the common ratio is also 48 divided by 96. Or you can also use 24 divided by 48, and that is 1/2. Okay, so that's where 1/2 comes from. Okay, after having our formula for the common ratio, so we will have our formula for our infinity. So we have s to infinity is equal to a sub 1 all over 1 minus r. Substitute the values. So 96 is our first term divided by 1 minus 1/2, which is also our common ratio. So solve for 1 minus 1/2, that's 1/2. So therefore, we got 96 divided by 1/2. Same as condition of example number 1, we have to reciprocal 1 over 2. That will become, let's show it. So that will become 96 times 2 over 1, or also equivalent to 96 times 2 is 192. 96 times 2 is 192 over 1. So simplify that further, we got 192. Okay? Let's proceed. What's the sum to infinity? We have 16, 12, and 9. Solve for the common ratio. So that is 12 over 16, or we can also use 9 over 12, which will be giving us 3/4. Okay. So after that, we will use the formula for infinity. Substitute the values. So 16 is our first term. So divided by 1 minus 3/4, which is our common ratio. So 1 minus 3/4 is 1/4. So 16 times 4 over 1, it will result to 64. Sorry, this will be correct. 16, let's correct that first. 16 divided by 1/4. So we should only get 64. So this will be deleted. That's only 64. Okay. So that's 64. That's the sum. Okay. Let's proceed. Find the sum of 8, 24, 72, 216. So always do the checking of the common ratio. So R is 3. So r is already greater than 1. So since r is greater than 1, then it is impossible to get the sum. This is not for infinity. It's impossible to get that because that's too big to compute. So we have nothing to do with it. Next, example number, find the sum of 250, 50, 10, and 2. So again, first things first, common ratio. That's 1/2 since we have to get here for the smaller numbers, 2 over 10 is 1/5 as our common ratio. So since it's less than 1, we can proceed to solving. So 250 is our first term minus 1 over 5 or 1/5. So the answer for 1 minus 1/5 is 4/5. So we will have to multiply it. We get 250. We will have to simplify this. It will become 250. Yan, I hope you got it correct. Times 5 over 4. Okay. So 250 . Okay, so we got 250 times 5 is 1,250. 1,250 over 4. So divide it further. So the answer for that is 625 over 2, which is already on the lowest term because these two are still even numbers, so it can be simplified further to this answer. Okay, I hope you have followed that. So we will now proceed. Find the sum of 5, negative 5, 5, negative 5. So as I have mentioned before, if our sequence is alternating signs but the same numbers, our ratio should be negative 1. And negative 1 will not be accepted since the condition states that it should not be equal to it should not be less than or greater than negative 1. Greater than or less or equal to negative 1. I'm sorry, less than or equal to negative 1. Okay, so it's impossible to get the sum. So we will skip that. So if ever asked, I will just write impossible. Next, find the sum of 3/4, 3/8, 3/16, 3/32. So that's 3/8 divided by 3/4. Okay, so half, 1/2 is our common ratio. So we can proceed. After proceeding, we can just substitute 3/4 our first term. 1 minus 1/2 is 1/2. So that's how our formula will look, our solution will look. And then doing the rule of division of fractions. So instead of division, we'll have to multiply the reciprocal. And then you can do the cross multiplication. You can do the parallel multiplication. 3 times 2 is 6. 4 times 1 is 4. Simplify it further, we will get 3 halves. Okay, so the sum of the infinity of this sequence is 3 halves. Next, find the sum of negative 19, positive 127s, negative 181s, and 181st rather, and 1 over 243rds. So our ratio is negative 1/3, so we can proceed. Negative 19 is our first term, so 1 minus negative 1/3, that is 4/3. So simplifying further, we get negative 19 times the reciprocal of 4/3, which is 3/4. So parallel multiplication, we have 1 times 3 and 9 times 4. Remember, it's a negative. So 3 over 36. Simplifying further, we will get negative 1 over 12. The greatest common factor here is 3. Divide by 3 in 3 and divide by 3 with 36. We got negative 112. All right, so let's have to remember this. Always check for the common ratio. As long as it should be less than or equal, not less than equal to 1, or it should not be greater or equal to 1. Okay, that's it. It should always be. So to be easier to remember, it should be less than 1 or greater than negative 1. Remember, when we say greater than a negative number, it should have a bigger number, or it should be a smaller number, because the greater the negative number is, the lesser the value. Okay, that's the 2 points to remember. So if there's any clarifications, you can just send me a message. You can call me, or you can schedule me another meeting. You can check also your Google Classroom for the learning materials that will be uploaded later on. So far, that's all for today. Thank you very much for attending the class, and goodbye.